In question 5a, a student wants to find how the resistance of a thermistor changes with temperature. In part 1, we need to draw a diagram of a suitable circuit that would allow the student to find the resistance of the thermistor. Well, we need a power supply, we need an ammeter in series with the thermistor, and a voltmeter in parallel with the thermistor. In part 2, we need to describe the procedure the student would follow to get accurate and reliable measurements of the resistance of the thermistor at different temperatures. The thermistor in the circuit shown above will be placed in a water bath, along with a thermometer to check the temperature, and a stirrer to ensure an even temperature throughout the water. Initially, a water-ice mix at or close to 0 degrees Celsius could be used, with the water heated by some method at 10 degrees C intervals to boiling point at 100 degrees Celsius. For each temperature, the student must record the current and the potential difference, finding the resistance in ohms from potential difference in volts divided by the current in amps. Each temperature should be repeated a further 2 times and the mean readings found. A graph of resistance against temperature could be plotted. In B, we have a circuit with a thermistor connected in series with a resistor R and a battery of EMF 6 volts and negligible internal resistance. At a temperature of 50 degrees Celsius, the resistance of the thermistor is 1.2 kiloohms, and the voltmeter connected across the fixed resistor reads 1.6 volts. In part 1, we need to find the potential difference across the thermistor. Well, the supply is 6 volts, and there is 1.6 volts across the resistor, so there will be 6 minus 1.6, which is 4.4 volts, across the thermistor. In part 2, we need to find the current in the circuit. Well, current is potential difference over resistance, which, for the thermistor, we know it has a potential difference of 4.4 volts and a resistance of 1.2 kiloohms, giving a current of 3.7 times 10 to the minus 3 amps. In part 3, we need to find the resistance of the fixed resistor, quoting our answer to an appropriate number of significant figures. Well, for this we can use resistance is potential difference over current. We know it has a potential difference of 1.6 volts, and the current we found previously will be the same throughout the whole circuit at 3.7 times 10 to the minus 3 amps, giving a resistance of 436 ohms. As our data here is to 2 significant figures, we need to quote our answer to 2 significant figures. In C, we need to state and explain the effect on the voltmeter reading if the internal resistance of the battery was not negligible. Well, if the internal resistance was not negligible, the voltmeter reading would be lower, as the terminal potential difference of the battery would be lower.